Hello everybody! Now we're going to do example C. Well, this is the probability that x is between 3 and 6. I hope that you guys can realize this is the same thing as the probability that x is less than 6 minus the probability that x is less than 3. Well, why is that the case? Well, if I draw a picture, here's my normal distribution and this is x. Remember my mean was here at 4. 6 is somewhere up here. So the probability that x is less than 6 is everything like that. The probability that x is less than 3, here's x is less than 3. So if I subtract that orange part out of the purple, what I'm left with is only the stuff right in here, which is bounded by x equals 3 and x equals 6. So that's actually the area that I'm after. So conveniently enough, the probability that x is less than 6 is something that we solved for within part A. So that's about 0.7486. I'm not going to round until I'm absolutely forced to. And now I have to evaluate this probability that x is less than 3. So this one is quite similar, I think, to part B. The probability that x is less than 3 is the same thing as the probability that z is less than 3 minus 4 all over 3. So that's the probability that z is less than negative 1/3. So again, I have this issue of, that negative value. So here's 0, negative 1/3. Without even looking at my z-table, I know that that's going to cause some problems because my z-table only deals with positive z values. So by symmetry, I know that this area here is exactly the same as if I looked to the right. So this area is the probability that z is greater than positive 1/3. And so that means that I can evaluate that area by doing 1 minus the probability that z is less than a positive 1/3. So now I need to go to my probability table. Let's see if I can make this a bit bigger. The probability that z is less than a third, so that's 0.3 repeating. 0.33 is here, so that looks like 0.6293. So coming back, I've got 1 minus 0.6293 as my probability that z is greater than positive 1/3, which is equivalent to the probability that z is less than negative 1/3. So my whole statement is the probability that 3 is less than x, which is less than or equal to 6, is equal to 0.7486 minus whatever this brown quantity is here. I'm going to use my calculator for that again. So I've got 1 minus 0.6293, and I get 0.3707. 0.3707. Is that what I said? That doesn't sound right. Oh, it is right. Great. So now I need to subtract those. 0.7486 minus the previous thing that I wrote. And I get 0.3779. There you go. That's the probability that we were after. Now you can check these with your calculator. Let's try that now. So if I check this one with my calculator, I'm going to go to my distributions menu. I don't ever want to use normal PDF because that's for at a particular value, which just, I don't even know when you would use that. It gives you the height of the function. Normal CDF is a lot more useful because it is exactly what we're looking for. It's adding everything up. So my calculator is very nice. It's telling me what we're looking for. The lower bound is 3. My upper bound is 6. My mean is 4. And my standard deviation, notice it's not the variance, it is the standard deviation, is 3. And I press enter. And I press enter again. And you can see that within 3 sig figs we are right on the money. So I hope that clarifies some things for how to solve these inequalities as well as how to use your calculator. Notice that if we had a standard normal distribution, you would not need to put in the mean or the standard deviation. That's all for now. Bye-bye.